Alright guys, let's look at the next question. The next question is question number 1, part 8. It says sine minus cos plus 1 and sine plus cos minus 1. It looks like I'll have to rationalize it. So let's just look at the terms. So this would be sine A minus cos A minus 1 upon sine A plus cos A minus 1. Again, I'm working with left hand side, so let me just write this. And now let me rationalize it by multiplying it with sine A plus, or rather not plus, plus is in the denominator, so I will have to multiply it with sine A minus cos A minus 1, and in the denominator also it will be sine A minus cos A minus 1. So this becomes in the numerator x minus y whole square, which means x square, which is sine square A plus y square, which is cos A minus 1 whole square, minus 2 times first term multiplied with second term. Done. And the denominator becomes x plus y into x minus y, which becomes x square, in this case sine square A, minus y square, in this case cos A minus 1 whole square. Good. Now let's just open the bracket in the numerator as well and the denominator and see how this helps us. So the first term is sine square A. When I open this is the form x minus y whole square. This becomes cos square A plus 1 minus 2 cos A. And when I open this becomes minus 2 times sine A dot cos A plus 2 times sine A. Done. And the denominator is, instead of sine square, I can write 1 minus cos square, right? So I can write 1 minus cos square A minus, and let me open this bracket, this becomes cos square A plus 1 minus 2 cos A. The only thing that we've done is, since sine square A is equal to 1 minus cos square A. That's the only thing which we've done till now. Good. Let's see how this would help us. Let's look at the numerator. Numerator, I have sine square plus cos square, which becomes 1, and this 1 plus 1 becomes 2. So I have 2 minus 2 cos A minus 2 sine A dot cos A plus 2 sine A. And in the denominator, I have 1 minus cos square A minus cos square A minus 1 plus 2 cos A. So minus 1 and minus 1 gets cancelled, and I have negative 2 cos square A plus 2 cos A. I think I should be able to take something common. I notice that there is a cos A common across. So let's try and look at these terms and combine them. So let me group these two together and these two together. So if I take something common, what is common is 2. This becomes 1 minus cos A. And in this, what is common is plus 2 sine A. If I take plus 2 sine A common, this becomes 1 and this becomes minus cos A. Now in the numerator, I have got 1 minus cos A common between both these terms. Let's look at the denominator. Denominator is 2 cos A and negative 2 cos square A. I think I should be able to take something here as well. So this is 2 cos A minus 2 cos square A. So in the numerator, again, I have between these two terms 1 minus cos A common. So let's just take that out. So this is 1 minus cos A times, in fact 2 is also common, so I can take 2 also common. So 2 times 1 minus cos A is common. So what I'm left with is 1 plus sine A. And in the denominator, I have 2 cos A common, and I am left with 1 minus cos A. So 1 minus cos A and 1 minus cos A gets cancelled. In fact, 2 and 2 also gets cancelled. So what I am left with is 1 plus sine A upon cos A. Oh, I didn't reach the answer that I was expecting. I still need to get here. I haven't reached this place yet. So then let me multiply this with 1 minus sign. Let me just rationalize the numerator, in this case 1 minus sine A upon 1 minus sine A. Maybe I could have done the same step in the first step itself, which means if I had rationalized the numerator instead of the denominator, maybe, but let's see how this works. So now this is x plus y into x minus y, which is 1 minus sine square A, and in the denominator I have cos A times 1 minus sine A, and 1 minus sine square A is nothing but cos square A, and in the denominator I have cos A times 1 minus sine A. So cos A and the second power goes here, which means I have cos A upon 1 minus sine A, which is nothing but my right hand side. So hence proved. Good. A longish question the way I've done, but interesting. We rationalized the denominator and then we reached somewhere and then we rationalized the numerator. Good. Let's look at the next question. The next question that we do would be question number 1, part 10. Let's look at it. So this is 1 minus cos A in root upon 1 plus cos A. Let's rationalize. I notice that on the right hand side, I need 1 plus cos A in the denominator, which means instead of multiplying with 1 minus cos A, let me rationalize with 1 plus cos A, which means let me rationalize the numerator. So this would be 1 minus cos A times 1 plus cos A. Again, I am starting with the left hand side, right? And in the denominator I would have 1 plus cos A times 1 plus cos A. Everything is in the square root sign. Good. So the numerator becomes x plus y into x minus y, which is 1 minus cos square A, and the denominator becomes 1 plus cos A whole square in the square root sign. The numerator is nothing but sine square A, and the denominator is 1 plus cos A whole square. The reason would be since 1 minus cos square A is equal to sine square A, and when I remove the square root sign, this becomes sine A upon 1 plus cos A, and which is equal to my right hand side. So hence proved. Done. Let's look at the next question. The next question that we do is question number 1, part 12. It says cosec A minus cot A whole square plus 1 upon cosec A minus cot A. So again, I will start with the left hand side. I realize that in the numerator and denominator, I have cosec A minus cot A common, which means if I can convert 1 into cosec and cot, maybe I should be able to take something out. So let's see, instead of writing 1, let me replace 1 with cosec square minus cot square. So this is, and how do I get that idea? Because I want to cancel cosec A minus cot A and cosec A minus cot A somehow. So this becomes cosec A minus cot A whole square plus, instead of 1, I'll write cosec square A minus cot square A. And the reason is since 1 plus cot square A is equal to cosec square A. That's the reason. Next, and in the denominator, I still have sec A times cosec A minus cot A. Done. Now the numerator is, this is cosec minus cot whole square, and this is cosec square minus cot square, which means this can be written as cosec A plus cot A multiplied with cosec A minus cot A. Perfect. So what I had in mind, I think I am getting it there, which means I should be able to take cosec minus cot common in both these terms in the numerator. This would be written as cosec A plus cot A multiplied with cosec A minus cot A, and the denominator is sec A times cosec A minus cot A. Done. In the numerator, I have cosec A minus cot A common in both these terms. So I take cosec A minus cot A common, and what I am left with in the first term I am left with is cosec A minus cot A, and in the second term I'm left with is cosec A plus cot A, and the denominator remains sec A times cosec A minus cot A. So in the numerator and denominator, cosec A minus cosec cot A is common, gets cancelled. Here minus cot A and plus cot A gets cancelled. So what I have is 2 cosec A upon sec A, which is nothing but 2 cot A. So how? Let's just look at this. The numerator is 2 upon sine A because cosec is a 1 upon sine, and sec is nothing but 1 upon cos A, which means this is 2 upon sine A into cos A, which is nothing but 2 cot A, which is my right hand side. So hence proved.